Hello, my name's Timothy Laurent. This is my final project, IE Reader, for course CS 6460 Educational Technology, Spring 2019. IE Reader, its goal is to use NLP models to do open information extraction, um, normalize entities, and build a knowledge graph like visualization to show to users to improve reading comprehension. On the back end, we're using Python, so I'm using Flask and GUnicorn to serve the app, and Nginx for serving the front end assets. Spacy's is used for basic NLP processing, stop word removal, and sentence segmentation. And models from Allen NLP are used for OpenIE and coreference. Now over here you can see kind of these bidirectional LTSMs. For OpenIE, they concatenate vector representations of the of each word, and the predicate that is under consideration does some work to create probabilities for being part of the predicate, or each argument of the subject object predicate or subject verb predicate or subject verb object yeah, portions of open information extraction. In the coreference model, we take word and character embeddings, put them into bidirectional LTSMs with attention mechanisms, and concatenate this for all the spans, and then compare all the spans together in a supervised fashion, and they're trained to predict coreference. To just kind of illustrate the utility of these models, the coreference model was the state of the art in all these coreference tasks. Beat them by a lot, which is been the case with a lot of these deep learning approaches to NLP tasks. And the open information extraction also did a state of the art in many tasks, and then in some it had a much higher F1 but lower AUC. So I mean, it's a very robust modern model for open information extraction. For the front end, use React and Ant Design, which is Alibaba's component library, with Jed Watson's great React Select, Viz.js for network visualization, and Docker to package it all up and deploy it. So I performed a user study halfway through to look at the visualization, look at the effectiveness of the intervention of the projection. Here is an example of the survey that was given to people on Mechanical Turk. This one has a immunology passage here about what happens when T cells encounter pathogens, and vitamin D's role in that. And then there are a bunch of questions here, some of them which have no answer. This was given to about 30 Mechanical Turkers. That was the first condition. The second condition was the passage plus this graph that was derived from the passage. And then the third condition had no passage and only the graph. So let's look at the data. So we can see here that the score, the median score did seem to go down with the graph. There was some problems with the survey. The graph was very small, and it wasn't interactive the way it is in the web app. But what's interesting here to note is that even when there was no text at all, the median score was still 6 out of 9, which was one less than one less than this graph and text, and 2 less than the just text. So a lot of the information is getting pulled out, and it is intelligible. I think a lot of people just kind of gave up at a certain point, or had difficulty interpreting the graph because it's something new. People did report overall that it was slightly more difficult, And in all three cases, they had a high level of engagement. What I did notice that kind of clued me into some other problems with the survey is that quite a few people didn't end up finishing it, or just kind of started answering with the same answer. So I think it must be considered when you're paying people only 30 cents for a task, like I was for this study, that they may not be that motivated to finish. So here's a schematic of the UI design. There's a selector to grab different models. Right now we only have open information extraction, but we could add other models here, and that's implemented and it gets sent back to the server. Are some demo texts. There's a button to submit, and then an area to modify the output of the model, and then an area to put text, and then the model visualization. So let's look at the running model. This was all run with a Docker Compose up command, and we have, here's a different text, this immunology text. So this is about inflammation. It's talking about inflammation produces fever and dilation of blood vessels. Cytokines are released. Growth factors may also be released. Leukotrienes attract certain blood cells. So this is pulling out a lot of information. We have something a little simpler with about what pharmacists are. Pharmacists may be small business proprietors. We can try changing the Levenshtein distance parameter, and that does make things a little more compact. Here's a more complex New York Times article about the Attorney General and subpoenas. We see Mr. Barr scheduled to come before Mr. Nadler's committee on Thursday. We have a lot of complex kind of information with here. We will have to use whatever we can to enforce a subpoena on Sunday morning. And then we can change the Levenshtein distance. So let's see if we can make this graph a little more compact. So now we only have like 3 connected graphs, and we have more information. You can definitely see some of the UI issue with overlapping content. That we could do better with the nodes. But I hope it's clear that a lot of information is being captured here in relationships between the information that's in this text. So I think some future work, we could work on entity merging, work on node representation, so that we're sure that they're not overlapping, and that potentially they could have more rich content that would come from a place like Wikipedia. Definitely two-way hover and interaction between the graph and the text, and vice versa, and then potentially active learning to be able to train models to make them even better for doing these tasks. So IE Reader harnesses state-of-the-art deep learning models to present knowledge in a graphical format. It could be used as a platform for developing better NLP-powered assistive technologies. Thank you.